Today we will discuss about one of the very important aspect of liquid, that is viscosity. Viscosity and surface tension. These are the two important properties associated with the liquids by virtue of their important property of intermolecular interaction. So we have already seen viscosity in the case of gases, isn't it? So viscosity in gases arises as a result of the collision between gas molecules present in two different layers. Okay, but here it is slightly different. Here the viscosity is due to the interaction between particles present in a liquid. Okay, and both viscosity and surface tension, they are due to this kind of interparticle interaction existing in the system, or specifically existing in liquids. So what is actually viscosity? Viscosity, you can say it is the resistance offered to the flow. Resistance offered. Resistance to flow. Okay, so why there is a resistance? This resistance is due to the intermolecular forces of attraction. We can model the viscosity, isn't it? The viscosity or the reason for viscosity by the laminar flow, which we have already seen. The laminar flow of liquids can be represented in this manner. Suppose this is a stationary phase, right? So the layer just adjacent to the stationary layer will be moving with a low velocity. So let this be that layer. Now on moving away from this stationary surface or stationary layer, we can see that the velocity of the layer increases. It goes like this. Okay, so this is how you represent the laminar flow. The flow of liquids can be represented in this manner, and this is nothing but the laminar flow. Now, viscosity, as we have already said, is due to the interaction between particles present in these layers. Right, there is a mutual forces of attraction. There are so many types of interparticle forces, as we have already discussed. Which are they? The dipole-dipole interaction, dipole-induced dipole interaction, induced dipole-induced dipole interaction, or more prominently the hydrogen bonding interaction. Okay, so these are some of the types of interaction which can exist between these two molecules present in different layers, and that is the reason for the viscosity. So the resistance offered to the flow or the viscosity, there is a viscous force associated with it, and that viscous force is proportional to two parameters. One, the area of contact. The area of contact between these two layers. Okay, so the property is due to the interaction between two layers. So that viscous force or the dragging force or the shearing force, and that is proportional to the area of contact between two layers. Number one, and again it is also proportional to the velocity gradient dV by dz. So what do you understand by the velocity gradient? It is the difference in velocity divided by the distance of these two layers, the relative distance. Okay, so dV is the difference in velocity and dz is their axial distance. Suppose this is 0, if you put this as 0 and then this layer is at a distance z, so z minus 0, dz will be z. And velocity, say if it is v1, the velocity associated with this layer, and v2, the velocity associated with the second layer, then the difference will be v2 minus v1. So that difference is known as the velocity gradient. Now when you remove the proportionality sign and combine these two factors, you can obtain the viscous force is equal to a constant multiplied by area into dV by dz. Okay, and since this force is acting against the flow, a minus sign is also there, right, which means that our force is retarding the flow. So this viscous force, now the equation for the viscous force is equal to a constant eta, and this constant is called the coefficient of viscosity, isn't it? The coefficient of viscosity. Okay, so now you can use the units of this area, velocity gradient and force, and you can find out the units of coefficient of viscosity. The most common unit being the one which we normally use in our laboratory for measuring the viscosity is poise. Okay, it is, or more precisely it is micropoise. That is the most common unit of the coefficient of viscosity. Okay, so if somebody says the viscosity of a particular liquid is very high, that means its tendency to flow is very low. Okay, so the viscosity is related to the tendency of flow. Higher the tendency of flow, definitely the viscosity will be very lower. Okay, and the tendency of flow, the ability to flow, can be represented by another parameter known as the fluidity. Okay, fluidity represented by the symbol phi. And fluidity and coefficient of viscosity, they are inverse to each other, so we can say eta is equal to 1 by phi. So if you know the coefficient of viscosity, then you can easily calculate the fluidity. You just take the inverse. Okay, so that's the relationship between the fluidity of a liquid and coefficient of viscosity. Now, the next point regarding viscosity is, so viscosity, the factor, if you take two liquids, say water and glycerol, or benzene or glycerol, okay, we can compare the second combination, benzene and glycerol. Which one do you expect to be more viscous? Glycerol, obviously, isn't it? Because benzene and glycerol, when you compare, benzene is a liquid, it's a solvent which we use in our laboratory, and glycerol, okay, it is a trihydric alcohol, so you have 3 hydroxy groups present in glycerol. So glycerol is found to be more viscous than benzene. The reason being, the extent of interparticle interaction is high in the case of glycerol because of the 3 or even more hydrogen bonding present in it. Okay, because of the intermolecular hydrogen bonding present in glycerol. Okay, so that is one aspect regarding the extent of viscosity, that is how what is the reason for viscosity, the cause of viscosity, the interparticle interaction. The next aspect is the dependence of temperature. Okay, so how viscosity depends on temperature, or the effect of temperature. So as you know, when you increase the temperature, what do you normally expect? The interparticle bond, isn't it? So there is an interaction between particles present in these layers. So if you increase the temperature, there will be vibrations, and due to that the interparticle interaction weakens or even breaks. So if the interparticle interaction breaks, then normally the liquid started to flow very smoothly. So the direct implication is that if you increase the temperature, the viscosity of the liquid decreases. In contrast, what we have seen in the case of gases, right, when you increase the temperature, the viscosity is also found to increase. There the reason is, by increasing the temperature, the number of collisions between gas molecules increases. So there will be a natural increase in the viscosity. But here, the reverse thing is happening. The intermolecular forces are weakening or breaking, which lead to a decrease in viscosity. And that can be expressed by the equation, that is eta is equal to constant A into e raised to EA by RT, right? So eta is the coefficient of viscosity, A is a constant, T is the temperature. If you increase the temperature, automatically the viscosity decreases. So this equation you can use to find out the viscosity of two liquids. If you take the logarithm and find out the viscosity at two different temperatures, then you can easily find out the viscosity of a liquid at a particular temperature, given the viscosity of liquid at a standard temperature. Okay, so this is how viscosity is related to temperature. Now, how will you measure viscosity? Viscosity can be measured with the help of an instrument called the Ostwald viscometer. Ostwald's viscometer. So this is that glass apparatus we require to measure the viscosity. Actually, we are not measuring the viscosity directly using this apparatus, but we measure the time of flow of the liquid, and using that time of flow we can make use of the Poiseuille's equation and find out the viscosity of a liquid. The viscosity of a liquid, two liquids can be compared with the time of flow. Eta 1 by eta 2 equal to T1 by T2, where eta 1 and T1 are the coefficient of viscosity of liquid 1. Eta 2 and T2 are the coefficient of viscosity and time of flow of liquid 2. Okay, so if you know the coefficient of viscosity of one liquid, find out the time of flow of that liquid, then you take the unknown liquid whose coefficient of viscosity is not known, measure the time of flow, substitute in this equation, and then you can find out the coefficient of viscosity of the second liquid. Okay, so this is altogether the aspect of viscosity of liquids.